Okay, so the webinar this week is on using Multiaxis Toolpaths as a 3-axis output. Now, I do also want to go over that this webinar is a special webinar. It's part of our special webinars this month that we're allowing all customers, not only premium level support customers, to attend. Gives you everybody a chance to see what goes on in some of these webinars, and if it's something that you want to get into. At the end of the webinar...
Max, can you please come to your desk, please?
At the end of the webinar, I apologize for that, we will also be giving you guys a code for some discounts on some software and support membership upgrades or subscriptions. So we'll bring that up a little bit later on in the webinar. So what we want to do is we want to go ahead and get started with this. Like I said, we're going to be covering how you can use the multi-axis toolpaths out of like the 4 Pro or 5 Pro package to be used as a 3-axis output to get some custom type paths and linking and some things you just can't do with the normal toolpaths. Now, I do want to let everybody know that if you have any questions that you might have on the topics being covered, feel free to type those into the chat box on your panel. Myself and Sean are here to answer those for you as we go along, and I will leave some time at the end of the session for a few questions as well. So we're going to go ahead and get started with this, and as you can see on the screen here, the first thing we're going to look at is, you can see this is just a basic like channel, maybe in an S shape as you can see down through here with some toolpath down through it. Now the toolpath that's displayed in here is one that I did using the multi-axis toolpath. Output is a 3-axis to get a flow line type toolpath cut through here, where it's actually following the shape of the surfaces. Now I'm going to take this one out for now because we're actually going to come back and recreate this so you can see how this works. But what I want to do is I want to unblank a standard advanced roughing toolpath to show you how this one would go through here and some benefits of using the multi-axis over this one as well. All right, sorry about that. And as you can see, the advanced roughing is going to follow the shape of the channel, but it also turns. So if this was a wall here, you would, or if you wanted the tool to come out the side of this, you would have to extend it out, and it's going to turn. It's going to leave different types of cutting and different loads on here, where you might want just that continuous back and forth cutting motion. It also wants to start, as you can see, in the middle versus on the end, and do connections at that point. So let's take a look at how to apply a multi-axis toolpath to this to output in a 3-axis format to get the type of cut we're looking to do. So I'm going to blank this out here. Now, we'll go to Machine Setup, we'll right-click, and we're going to go to Multi-Axis Mill. Inside of here, you have the different multi-axis toolpaths. The ones we're going to look at are the surfacing ones, and I'm going to show you a couple different examples of these during the webinar and how you can use those. Again, I want to let everybody know that we will have this webinar recorded to be posted at a later time, and we will try to, if it becomes too bad, replay this webinar another time. If I can, if everybody's having some issues with the webinar, if you want to send us your email address, you can send that to training@bobcad.com or just chat it into me in the chat panel. I'll do my best to get make sure we get the link to this out to you, or the ID for the next meeting if we have to redo this at another time. I am getting a lot of people getting bad sound come through, I understand, and I do believe it's due to internet issues that we've been running into here today. What I'm going to do is I'm going to give this just a second longer and see if it clears up, and then we'll continue. So I'm going to put it on hold for just a moment. left on the part. You can do full cut, avoid at edges, start and end at exact surface edges. So we'll leave it at avoid cuts at edges. What that'll do is keep the toolpath off the actual edge of the part. If I do start at edges, you can see that it will start the toolpath right at the edge. And again, the offset would be your allowance, like how much you wanted to leave on there if you were using this as a rough. And we'll come back and show you that. Over here, you have your tolerance, just like in all the other toolpaths, your step over. You can also define this by a cusp height. So you can give it a step over or cusp height. We'll go at 100,000 step. Let's do 50,000s. Directional cutting, one way, zigzag. Cut order. You have some standard cut orders here, as you can see. And you can do climb, conventional, clockwise, counterclockwise, depending on the method of cut. Now, the tool axis page is going to be the one we're going to use to change the format output. It's going to default to 5 or 4, whichever package you have. But what we're going to do is we're going to switch it down to 3. And as you can see, what it does is it turns off all those tilt controls because we're not tilting the tool or the axes or rotaries or anything like that. We're just looking to get that output as a 3-axis type toolpath. You can still apply gouge checking, so you can use the gouge checking that comes with the toolpath. We'll come back and look at that. And you can use all the additional link options on entry, along a cut, between slices, and even between passes and such. You have different retract type options in here, where you can go from plane to cylindrical to spherical type retract options. You can adjust the heights. You have your lead in and out options. You can see there's all kinds of additional lead in and out options that get added for you to use with the toolpath. So it's like adding additional 3-axis toolpaths into your software, but allowing you to actually come in and control every aspect of that toolpath. So we're going to leave the defaults. We'll come back and look at all the roughing options we can turn on, and then you get some additional options inside the utilities. The way you want to attack these toolpaths is set just the basics first and make sure to get a good output. And then you're going to come back and start tweaking it in and adding the roughing in and stuff like that afterwards. So let's go ahead and go down here and hit compute and give this just a moment and see what we get. So as you can see, the toolpath is starting here, working down this wall, across the bottom, and up the other wall. So that's the type of cut that you're getting there. And it's starting with the shape, if I go to a top view, and let's change the color of this toolpath as well. And it's staying with the shape of the path though. It's starting with the one edge shape, and as it transitions across, you can see these curves get tighter to match the other edge. Now, we could tighten this up and give a good finish to it. So let's go back into the multi-axis and edit. And this is where you're going to start tweaking in your settings. So we could come over here to our step over. Maybe we want to bring this down to 10,000 step overs. Let's compute this one real quick. And you can see you have a lot tighter toolpath through there. Hit the wrong button there. Or what we can do is maybe we want to use this as a start of a rough out. But I want to take one tool, maybe the width of the bottom channel, and just go back and forth like we had before, or just stepping down that pass. What I would use in that case is determine number of cuts. And I'm going to leave it at 1 at first. And just recompute it. And it's just going to give me one pass centered between the two edges that I picked on the drive surfaces, which you can see is right down at the bottom. Now you'll also notice it's stopping right at the end. If I want to get it to extend out either side a little bit more, we can use the extend trim. Even though these are grayed out, if you check them, they become active. So as you can see, we can add or shorten off of the ends of the part. So let's go another 1/2 inch off of each side of this. You can extend it by a percentage of tool or distance. And then we'll just recompute that. And you can see how I've extended that out the side of the part. So what we can do now is we can come back into it, go over to our roughing page. I can turn on depth cuts. Go into here. I can say, you know what? I want to step down 10 times at 30 thousandths. You can also do additional like finishing passes in there. You can apply the depth to the whole toolpath or just the first pass. You can do it by passes or slices depending on how you're clearing out the area there. We're going straight down, so we're just going to leave it as the defaults and press OK. And then we'll just recompute this one. And if I zoom in there, you can see it just gave me those passes straight down, but still following the shape of our surfaces. So let's simulate that real quick just to show you how it's cutting. And then we'll show you a couple other examples that you can do with this toolpath. Again, if you're experiencing any sound issues, and if you want, please email us to training@bobcad.com so we can send you a link to this as well as an invite to another webinar. Also, if you just want to type into the chat box, myself and Sean is also trying to chat back and forth to you guys, and he'll be able to give you some information as well. You can see with the multi-axis toolpaths as well, it comes with the Pro simulation. So you'll be able to set up your machine, draw your components and set them in there, and actually see the entire machine run in your simulation. Check collisions, fixtures, heads, and things like that. So let's set this here, give it some speed, slow it down a little bit, and hit play. And again, my stock is just a block, so you can see that would be starting off of where the S was. But it's just following that shape, just going back one direction. Now I can change it to zigzag, and it would go zigzag back and forth in there. I can change the up and down link types. Whatever you want to do with these toolpaths, you have a lot of control over them once you come to this method. It's almost done there, and you can see it's just following the shape that we wanted of our surfaces. And that's the last pass. So you could use that as a rough out. It could be a finish. You know, if you have a tool that's maybe the shape of the channel, a lot of people want to walk that tool just down the center line. That's the perfect toolpath to be able to do that. And you can use that, your own ground up tapered flat bottom tool for that. Okay, so I'm going to close the simulation. The next one I'm going to show you here is a different type of way to use these. And this would be one that you can use just to clear off a surface quickly and get a good controlled step over. A little bit different than the slice planer would be, because I've had people look at this and say, oh, it looks like a slice planer going across the part at 45 degrees. Well, in a way it is, but what a slice planer does is if you give it 100,000 step over, it's going to start here and it's going to start stepping over 100,000. It's going to go up and down over the shapes of the part. But if it was to encounter maybe a wall right in between the 100,000 step over, it's not going to finish that wall or cut to that wall. It's going to cut maybe 50,000 short of it, lift up, go over it into the next 100,000 step over, and then continue on across the part. It doesn't vary and look at the surfaces in a way that this toolpath will. So what this one is let's get this one out of here and show you what we did with it. Delete. We're going to do another multi-axis. This is another one, and this is cuts along a curve. The way this one works is you define a path, and that path could be a line, a spline, or arc. The toolpath that's generated, like the picture shows, will be at perpendicular or 90 degrees to that path you select or create. We'll use the work offset 1. You get your multi-axis posting in this version of the software right there on the fly if you need to come in and change any of those. But that's grayed out, as you can see, because we're working in 3 axis at this time. We'll just use the 1/2-inch ball end mill for this. Okay, so that curve, like I was stating, it can be on the shape of the surface, it can be bent, it can be a straight line in the air above it like we have. And that's called your lead curve. So we're going to go ahead and select that. I just have a straight line from point to point. And then my drive surface is going to be what the surfaces we're actually cutting again. Again, you have your types of cuts. Avoid, start, limit by 2 points. This one's nice if you only want to cut a certain area and you can have 2 points on the screen somewhere that you want to pick. It will only allow it to toolpath between the distance of those points. You can extend it. You have your step over and so forth. And we're just going to do 100,000 step over for right now. Directional cutting. And we're going to come in here and change it to our 3-axis output again. You still get your gouge checking options. You still get your link controls. It gives you some additional ones as well, like we talked about, like the direct, the follow type. You get a blended spline type curve, step type curves, retract to different areas as well. You get all the roughing options and some different utilities, which allow you to control feed rates in different zones. So you can define a zone and control that feed rate, whether it's inside or outside of that zone at different percentages of what you set. So let's go ahead and compute this and see what we get. And as you can see, it's giving me a toolpath. It's in blue. Let me change the color of it so we can see it a little better here. So there you can see the toolpath across the part. It's staying perpendicular if I go to the top, 90 degrees to my lead curve, but it's curving and following the shape of that surface. Now this is one way, so you're seeing all those retracts up there. If we want to make it zigzag, we can come back into the toolpath, go back to our parameters, and just change it from one way to zigzag. Compute it. Now we don't have as many retracts because we're actually linking over and going back the other way. And as you can see right now, my links are set to retract. So let's keep that down on the part. Let's go back to our parameters and go to our links. So now we want links between slices. We have large moves set to retract to clearance area. I'm going to have it follow surfaces and recompute it. Now you can see my retracts go away and it's following the surface shape on the step over. So it not only gives you the ability to control your lead in and out, it allows you to control every step over and link that you come across in the toolpath. Now we can also limit the amount of cutting just by shortening this line. If I went to Utilities, Trim and Extend Screen, picked this line and then trimmed it back to right here. So you see how I shortened the line? What we'll do now is we'll go to our lead curve. I'm going to remove the old one, select the new one, and then I'm going to recompute this toolpath. And you can see what it did is it just shortened my toolpath up to that point, not allowing it to go over any more than that. So you can limit how far it cuts across a surface with this toolpath as well. We can turn it on to roughing. Here, let me bring that back across the part. I'll just undo that. Reselect the full curve again. And then recompute it. We're back across. Now we're going to go back into the toolpath. We'll go back to parameters and we'll go to roughing. We can use multi-passes inside of here. We can say I want maybe 6 roughing passes, 100,000 step down. Compute it. Now I'm using it as a roughing toolpath. But notice the roughing is staying true to the curve. It's just offsetting each toolpath up, or the toolpath up 6 times at 100,000ths. If I want to trim this off out here, there's actually a setting inside of here for that. And that's turn on the stock definition. And you can see it trims it off outside the stock shape. So all these little controls are now at your fingertips to use to make your paths optimal. Better finishes, better roughing, better cycle times, better tool life and wear. All these things allow you to get this out of this parts. Again, if anybody has any questions during this presentation, feel free to type those in to your chat box on your control panel. As we're going along, I have Sean here as well. He's going to be typing back answers to you, and we'll try to cover them. And again, we will have a little bit of a question and answer session at the end of this. Okay. Also, remember, we're going to be talking about a coupon code at the end that will give you some discounts on software and support memberships. The next example I want to take a look at is just something I threw up here just to show you. It might be something that you could use or not. But I have this little piece of bar here with this open channel on the end. Some of the toolpaths sometimes don't give you an optimal cut or the type of cut you're looking for. As you can see, I've used these toolpaths to create a cut where the tool is walking in and around and out on the end of it. The toolpath that I use for this is the morph between two curves again. I mean, you could use parallel to surface or parallel to multiple curves and have it follow that shape around in there also. But we did morph between two curves. It's a 3/8 bull nose end mill. The first curve, as you can see, I just picked a little bit of the top. I could have stopped here if I wanted to. The second curve, I picked the bottom inside. And then what it's going to try and do for my drive surfaces, I picked just the walls I wanted to cut between them. And it's going to try and morph from the top shape to the bottom shape along those drive surfaces. I did full cuts, avoid edges. I even extended it out a little bit farther. One directional climb mill and a 50,000 step over. I outputted it as 3-axis. Increase my links, because you come in here and you can increase the height of the links and everything, or the retracts. Didn't turn on any roughing or any of the utilities. And you can see the type of toolpath that's generated off that. Just wanted to show you with this that you can really get some different types of cuts out of these toolpaths just by changing a few of the settings inside of it. Let's say that we wanted to do a little bit of a different type cut on this. Let's go back into that toolpaths type. And let's go to parallel to multiple curves. We'll use the same end mill. Okay, so what we're going to do up here is we're going to come in and edit our curves. And for this, I'm going to pick these bottom curves here. Make sure I got them all. And then the drive surfaces, we use the same drive surfaces we already have selected. I'm going to leave the settings the same. Output is 3-axis, same links and everything, and just recompute it. Let's see what we get. So now I've got a little bit different of a cut. This might be a little bit more efficient for you. As you can see how it's trying to come in there and cut that out. So this is something, if you want to control these, you can reduce those back. Limit it down. But if you had that cleared out, that would be a fine entry where it would come in and try and clear a little stock out there. And it keeps coming in more straight as it gets down into the channel a little bit more, following that shape. Very easy to do, picking off of the model itself and getting some really nice tool paths and links and connections. And you can see it's actually going down through that radius there. Another example of this is this type of a cut here. Now what this is a shape where you might want to just run around this, stepping inward, cutting this ramp out. And without these toolpaths, you would have to get the intersecting edge of the two surfaces, create your own offset of the tool, because the toolpath, with you drawing your own toolpath, won't do any offsets. And then, copy it over and use the 3D project or 3D engraving toolpath to cut that out. This one, we can actually toolpath right off the part, and we can get the toolpath to be compensated for whatever flat bottom or ball tool that we're using. Very easy to do, and you can see how I was able to extend those over as well to make sure that they come cleaned in. Again, to do a toolpath cut like this, as you can see, we have a couple different ones here. I actually, if I unblank this, you can see I did another one in there around the top, kind of like a step down as well. We'll just leave that blanked out for now. And this is the one that I wanted to look at here. And you can see this is parallel to multiple curves. It's working off of the inside curve, as you'll see as we go through this. So our multi-axis machine setup. This is just a 1/2 inch flat bottom end mill, no corner radius at all. The edge curve, this one I picked the outer one. You can pick the inner one, you can pick the outer one. Just depends on which way you want to go with it. And then the drive surface obviously is the surface that I'm cutting. I'm not doing any type of an offset. I'm avoiding the exact edges, but I did turn on the extend and extended it out 1 each as a value each direction. You put a minus number in here. As you can see in the little diagram, it would be shortening it up so it wouldn't go off the end. Default tolerance, 200,000 step over. Again, you can control it with cusp height if you wanted to. This is doing a zigzag standard pattern. Output is 3-axis. Again, takes all the complexity of the tilt angles and everything out of your toolpath. I don't have any gouge check on at the time. And the links that I'm using, I'm actually using a blended spline between slices. That'll be that curve you'll see on the end of it. And a direct along cut. I have no roughing on, and just the defaults for the utility options, speed controls and such. And if you look at it like the blended spline would be the link type here, instead of a direct over. And we can show you an example of that. Let's zoom in so you can see these links a little bit better. And let's go in and make a change to them so you can see what happens. Let's go to the links page. So instead of a blended spline, let's do a direct and recompute it. And we'll give this just a moment. So you can see a direct is just like it says, direct connection. That's the one thing about these toolpaths that you want to understand. And even with any of the 3-axis and 2-axis toolpaths nowadays, is once you generate it, take a look at your toolpath on the screen. If it's not what you want, go back into it, make an adjustment, recalculate it. Look at the toolpath generated on the part, look at the simulation, start tweaking it in. It's a lot easier to get the basic toolpath calculated first and then tweak it in from there than to just try and go right to the finished product the first time. And guess on half your settings probably as you go through it. All right, let's go back to the links. We can also use follow surfaces, step, retract to feed distance. So if I was to choose retract to feed distance, let's show you what you would get on this one. So what that's doing is retracting up to the distance that it would feed into that surface before it steps over and comes back down. So let's put it back to blended spline, recompute it, get it back to that point. So you can see, very easy to do. Again, if you want to stop it short on a surface, go to our extend and trim, minuses in here instead of pluses, and this should go back in that way 1 inch, as you can see. All right. Some of the things you want to notice inside of here as well is a lot of these toolpaths can be used for a lot of different types of cuts, pretty much to give you the same result. It's just think about what you're working with on the CAD model. How's it going to be easy to select? Would it be easier for me to pick the surfaces versus the curves or the edges? Would it be easier for me to pick the edges versus the surfaces? Same with parallel to multiple curves or parallel to surface. Kind of the same thing there on that one. So just be aware a lot of those will give you the same result, or can be, the settings can be adapted to get the same result depending on what you're picking off of the model. A couple other examples we want to go over while we have some time is an undercut. With your 3-axis or 2-axis software in BobCAD, the software will not do undercuts. If it was trying to cut this out, it would just go straight down the wall. Would not allow the tool to come under here if you were using like a lollipop or bell type cutter. The multi-axis output as a 3-axis toolpath will allow you to do undercuts. And let's do this one as an example just so you can see this type of a cut. So just to show you here the type of toolpath that we would be looking for, and you can see how it's curved, and that would be representing the shape of the tool. So I'm just going to run a simulation of what we're going to be achieving with this so you can see what we're working towards here at this one. Since there's already Toolpath on here before I delete it off. We'll give this just a minute to open up. We always have people calling in wondering how they can do undercuts. This would be the best way to do it with the software. I'm even going to turn the machine off for this real quick here. So what the first tool is going to do is just rough that out for me real quick. I'll actually stop that, as you can see in the simulation, and drag that across. And then we'll see it switch over to the lollipop tool that was defined. And you see how it's just starting here and running down around through there, cutting that out for us. Completing the undercut. So, real good application for these types of toolpaths. Now, how do we create that toolpath? Well, let's show you some of the settings that we've done in here. Let's go into Edit. The toolpath on this one, I used Morph Between Two, just like we've used before. This is a lollipop style tool. You can see it's a 5/8 diameter with a 3/8 shaft. Allow it to fit down in there and reach. First curve, top of the part. Second curve, other top of the part. Don't have to worry about picking down these edges. It's the same thing, whether it's here or here. It's the same edge, so you don't have to worry about reaching down in there. If it's a straight wall, just pick the top one if it's the same. And drive surfaces, obviously, is the undercut shape down at the bottom. Not the walls, or we'll try and cut those too. If you want those to be cut, you could select those also. I'm avoiding the exact edges. I'm extending it out. The diameter of the tool will give me type of like a lead in and out the end of the part. I'm doing a 20,000 step over at the default tolerance. I'm doing a zigzag style cut. Output is 3-axis. I do have gouge check on. I'm checking the flute and the shaft as it's retracting against the drive surfaces and the upper walls to make sure that it does not collide there. If it collides there, depending on the settings you have inside the gouge check, will allow the toolpath to correct itself or eliminate that port of cutting. The links are direct, like we were just talking about. I don't have any roughing on. That's just the finish pass through there, and I'm not adjusting the speeds. And you can see the type of a toolpath that would calculate. So it really allows you to pick up some nice toolpath cutting through there. Now, what would happen if we did pick the sides? Let's go back in here to the drive surfaces and add these into it as well. And then I'm just going to recalculate it real quick. Remember, we picked the straight walled shapes, and as you can see, what it's trying to do is go down the wall. Now, remember, your toolpath is always the bottom tip of the tool. So picture the ball, full diameter contacting here, working down this pass, and then down through here as well. So you could use it to finish the entire thing. You can turn on the roughing, just like we've done in any of the past. Drive surfaces, reselect. I'm going to turn that one off, and that one off. And recompute. And as you can see, if you're curious if that might be a better cut for you, it just takes a couple minutes usually, depending on the toolpath calculation times, to change the surface selection and recompute it. Take a look at the new toolpath. One of the next things I want to cover is using the projection toolpath. If I just show you inside of this one before we actually bring up a model and create, we have a project curves toolpath. And if you look at the picture, you can see there's just a spline or a curve or a line that's flat drawn above a curved or wavy surface. What this toolpath is it's similar to the, let me go in here. It's similar to the 3-axis wireframe or 3-axis engrave, where the tool will follow the cut path, but it will take into consideration the tool do the offsets for you and everything else like this toolpath will not. So it's a very handy method for doing custom movements, designing your own toolpath that you want the tool to follow and such. I'm going to show you an example of that now. What we'll do is we'll open another file here, see if I have it. Forgot to open this one up prior. That's okay, we can grab it right now. I'm going to delete all this toolpath off this part using the delete all features. And as you can see, this part has a nice wavy surface to it. Let's say I want to have a tool that walks around a special shape in here, cutting a groove or something like that into the part. So let's go to a top view. Now let's create our path. I'm actually going to do this into additional layer. I'm going to call this cutter path flat. I'm going to put the check on it because that's the one I'm drawing in. And what I'm going to do is I'm actually going to make this transparent. And I'm going to go to line continuous. And I'm just going to start sketching out the path that I want this to follow. And I'm actually going to add a couple curves into this as well. And one more here. Oop, that don't fit there. We'll leave that one sharp. So as you can see, what I did is I just sketched out a flat path. And we're going to get it to bend it to that surface. So in our cam tree, let's check out our stock. Make sure our stock and our zero are okay. And then what we'll do is we'll come in here, do a mill multi-axis, surfacing, project curves, work offset 1. We're going to use a 1/2 inch ball end mill. Okay, so here we're going to pick our curve. So that's going to be this chain here. I'm going to hold my shift key and chain select it and OK it. My drive surface is going to be this one surface here. I don't have to worry about the rest of the model. You have different types, user define, spiral, offset. Let's try the user define first here. Projection distance. Cutting along the center, left side or right, so you can offset it to one side or the other, just like cutter comp would. You can do your extensions, as well as all of these toolpaths. We didn't talk about this, but they have 2D containment, which is like the boundaries in the 3-axis toolpath. So you still have the ability to use those as well. Cut tolerance. We'll output this as 3-axis. You still have your gouge check capability. We won't need the links. Maybe the first entry and last is all we need. And your roughing, you can step it down, as you'll see, in your utilities. So let's compute this and see what we get. All right, so we're going to need to use the offset option. So it allows it to take the tool into consideration. And it's taking it just a moment. Let's check this again. Check my tool. 1/2 inch ball end mill. Projection, offset, projection direction. I need to go into Z. That's probably been my whole problem. Apologize for that. You need to set which direction the projection is happening. We want to go up and down into Z. Let's just recompute. That'll take care of it right there. Yeah, my fault. Sorry. Been one of those days here, especially with all the internet problems and everything. But if I change the color of that pass, you can see what it did is it took the path that we told it and it's just going to project it right on there. But it's doing the compensation for the tools that you've chosen. Big benefit, real quick way to get that your own type of defined cut out of the software. Again, if we wanted to come into this feature, go to the roughing, Maybe turn on some depth cuts. Maybe I want to do 6 of them at an 1/8 inch step down and recompute it. Now I've got a roughing, stepping down. Maybe you're doing a billet on a part or you're just a little channel and it's got to go up and down and over some stuff and you want the tool width to just follow this path that you've created, stepping straight down, but still compensating and offsetting for the tool shape and size that you have selected. So what I mean by that is if I came back in here and switched this to a flat end mill and recompute it, it knows it's using a flat end mill and it changes the tool path for that end mill. So whichever of these that you choose, it will take that into consideration. Remember, it also gives you your custom tool shapes in here, tapered, T-cutters, dove mills, lollipops, chamfer mills. All that comes into consideration as well. So what I want to do now is I want to open up to any questions anybody might have on the topics that we've went over. And right before I do that, though, I did mention that I'm going to have some coupon codes for you here for additional products and software. Again, apologize for any internet issues or anything that we've had at the beginning or through the webinar. If any of you are interested in seeing this recording or an additional webinar on this at a later time, please email to training@bobcad.com and just let us know you were attending the webinar, or on the control panel there in your little chat box. Just send us your email address and we'll make sure we send you a link to where we'll be posting this webinar recording. And we'll also be sending you a link to the next webinar also. But like I was saying, we are going to offer anybody that gives us a call by this Friday, the 13th, a 20% off the 4-axis Pro upgrade. And all you got to do is give them coupon code KHS. I'll just type that on the screen here so you can see. The letters KHS. If I go to a top view, would help. If you just give that coupon code over the phone, they'll know to take that discount out. Or if anybody is interested in upgrading or acquiring the premium support membership, which gives you access to these webinars, we try to do them weekly, depending on holidays or scheduling. They're usually every Wednesday from 2 to 3 p.m. I know at the end of the year and the holidays and stuff, we haven't had that many. But once we get through the end of the year, we're going to be ramping these back up again. They're really good in-depth ones. We cover a lot of topics. And we ask customers to send in topics they would like to see in the webinars as well. And we spend an hour on them, question and answer session at the end. Really good webinars. But if you give them the same coupon code, KHS, they'll take $50 off of either the upgrade or the subscription to the premium support. So again, that coupon code was KHS. And again, if anybody has any questions on anything covered, feel free to type them in your chat box. Me and Sean will do our best right now to answer them for you. Once we get done with that, we'll go ahead and wrap up the webinar for today. So I'll give it just a minute while you type in any of those questions, and then we'll go ahead and answer them for you. Okay, it doesn't look like a lot of questions are coming. It looks like Sean got most of you guys' questions going through there. Again, I want to go over that coupon code KHS, good deal there. The premium support, remember, not only does it give you access to these premium webinars, additional videos online, all the previously recorded webinars that we've done are up there on that site for you to go watch it anytime. Anytime we do a webinar, we record them and stick them up there. It'll also comes with 2 hours of online training, which is great. That covers the cost of usually the product right there, but to give you an additional $50 off that is kind of nice. So again, if you call into us by this Friday the 13th, give the coupon code KHS. They'll either give you an additional 20% off the 4-axis Pro upgrade so you can get into these toolpaths. If you're going to be using them to just output as 3-axis, the 4 Pro is all you need because you're just using the strategies. And again, the $50 off the premium support upgrade or service membership. So at this time, I would like to thank everybody for attending. Again, get those email addresses into us. We'll send you out some links to some more webinars we'll be doing for this, so we don't have just in case we have it due to the technical difficulties, we'll try and rerun one of these again. Plus, we'll do some additional topics for everybody. And again, if you can get into that premium membership, that way you can get into our weekly Wednesday webinars that we're going to cover a lot detailed stuff that's coming up here. Some good trainings we got set up for that. You can either type it into the chat box on the control panel there or email training@bobcad.com. So I want to thank everybody for attending, and we'll see you at the next webinar.